Assalamualaikum students. We have the next question is the function. We have a function, and the function, the domain of the function is the real numbers. That mean all real numbers, and we have to show that the values of f is strictly increasing if the x is belong to the interval in 4 by 5 and to the infinite, or if x is belongs to the minus infinity to minus 3 whole by 2, and but it is strictly decreasing if the interval is that. So if we have to now, first of all we have to know that when the function is strictly increasing and the decreasing, we know that the function is f is strictly increasing when the on an interval when and the, for example, the interval is AB, and there is a point is belongs C is belongs to A, then the function is strictly increasing when the derivative of f is at C is greater than 0, and the f is strictly decreasing when the function, the derivative of the function at the point C, the from sum of the here from the interval, it is less than 0. So we have two these condition, and we have the questions, and we have the intervals. First of all, we have to now we have to find out the derivative of the function, because with the help of the derivative of the function we can be find out that the function is decreasing or increasing. So the derivative of the function is the derivative, we take the derivative by the constant rule we apply here, as the denominator 40 x square plus 60 x plus 193 and whole square, and we take the derivative of the function, or we say the polynomial above or in the numerator. So we have 60 x plus 20, and we know that the constant value have the derivative 0, and 40 x square plus 60 x plus 193 and minus, and then we take the derivative of the denominator to 80x and plus 60, and then it will be into 30x square plus 20x and plus 111. So we write here as, after the multiplication and minus, we have this value. So now first we have the first interval is that x belongs to the 4 by 5 to the infinite. So for x is belongs to 4 by 5 to infinite, then let us take a number from this interval, and we have, if we have the real line, then we have 0 and we have 1, and up to so on this goes to the infinity, positive infinity. Then 4 by 5 we have some here, so we take, let's, where the point is 1. So if we have, let 1 is belongs to 4 by 5 to infinite, then the derivative of the function at point 1 is equals to, that is the 1000 into 1 square plus 2700 into 1 minus 2800 over 40 into 1 square plus 60 into 1 plus 193 and whole square. So after the addition multiplication, we get the value is 900 over 293 whole square, and if we solve next this value, then we get the greater than 0. So the derivative of the function at a point is greater than the 0, then this implies that the function is strictly increasing in that interval. Strictly increasing in the interval 4 by 5 to infinity. Then now we take that second interval, that is for x is belongs to the interval is minus infinity to minus 3 by 3 whole over 2. So if we have this interval, the interval is like that. If we have 0, we have minus 1, minus 2, minus 3, minus 4, and up to so on the negative infinity. Then the point is minus 3, 1 by 2 is at here. We also say that this is the minus 3.5. So let us take the point 4 from the interval. So minus 4 is belongs to the interval minus infinity to minus 3 whole 1 over 2. So we take this and substitute in the derivative, and minus 4 is equals to 1000 and minus 4 square plus 2700 into minus 4 minus 2800 and over the value is 40 into minus 4 square plus 60 into minus 4 and plus 193 and whole square. And after this multiplication and addition, we have the value is like that 2400 over 593 is square. And we again next we solve this value, then we have absolutely have greater than 0 value. So the function is also, this implies that the function is increasing in the interval is minus infinity to minus 3 whole 1 over 2. And now we have the third interval. For x is belongs to negative infinity to minus 3 by minus 3 whole 1 over 2, and the value is, so we have this. Next for the third interval we have for that is the axis belongs to minus 3 whole 1 over 2 to 4 by 5, and we know that from the real line it is here, it is minus 3, and the minus 3 whole 1 over 2 is here, and we have minus 2, minus 1, 0 and 1. Then the other point is 4 by 5 is here. So we take the any point from this interval. Let us take minus 1 for our easy. Minus 1 is belongs to the minus 3, 1 by 2 whole and 4 by 5. So we put the value in the derivative, that is minus 1, and the value of the derivative is 1000 into minus 1 square plus 2700 into minus 1 and minus 2800 over 40 into minus 1 square plus 60 into minus 1 and plus 193 and the whole square. And after we multiply and addition, we get the value is minus 4500 over 173 square. And because of the negative sign, we now that after the division we get the value is negative, so it is less than 0. So by the first point we discussed starting in the question, this implies that the function is strictly decreasing in the interval. The interval is minus 3 whole 1 over 2, 4 by 5, because the derivative in that interval is less than 0. So we have the question and we solve this, that we have three intervals in the question, and we prove that the in the two intervals we have the function is strictly increasing, and one interval the function is strictly decreasing.